Hello, my name is Sophia, and today I'm going to be discussing the skeletal structure of the compound Xanax. So with Xanax, its chemical formula is C17H13Cln4. And with blue marker, I'm going to be showing you where all the carbons are in the skeletal structure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then with red marker, I'm going to be showing you how many hydrogens are attached to each carbon. So on this bottom ring here, all of the carbons except for this carbon is going to receive one hydrogen because this carbon is already has 4 bonds. 1, 2, 3, 4. And then in this structure here, this carbon's going to receive 2 hydrogens. This carbon's not going to receive any hydrogens, nor is this one, nor is this one, nor is this one, because all of these 4 carbons already have 4 bonds to them already. And then same with this carbon, it already has 4 bonds. This carbon's going to have 3 hydrogen. And then in this last ring over here, all the carbons except for this carbon and these 2 are going to receive 1 hydrogen because these 3 carbons already have 4 bonds. So it's going to have 1 hydrogen, 1 hydrogen, and then 1 hydrogen. And so now I'm going to talk about chirality of the molecule. So for Xanax, this is an achiral molecule because all the carbons within the structure do not have 4 distinct things connected to it, or they only have 3 things connected to each carbon. For it to be a chiral carbon, it has to have 4 different distinct things connected to the carbon. And so now I'm going to draw out and circle the different functional groups within the molecule. So for this nitrogen right here, this is a tertiary amine because there's 3 carbons bonded to it. And then for these 2 nitrogens, they're primary amines because they only have 1 carbon bonded to them. And then for this last nitrogen, it's a secondary amine because it has 2 carbons bonded to it. And then another distinct factor about this structure is that it has 2 aromatic rings, one right here and one right here. And now I'm going to choose 2 different elements from this structure and show you the hybridization and the geometry of it. So we're going to choose this carbon up here. So this carbon, its hybridization is going to be sp3 because it has 4 things bonded to it, 3 hydrogens and 1 carbon. And so its geometry is going to be tetrahedral. And then I'm going to choose this nitrogen right there. So for the nitrogen, its hybridization is going to be sp2. And that's because there are 3 electron groups. It's attached to a carbon and a nitrogen, and then it has its own lone pair on top. And so the geometry is going to be bent. And that wraps up the conclusion of the molecular diary entry.